Okay, now let's look at the inverse of the cosine function. First, if I were to just graph a couple periods of the cosine function, you can see it's not going to pass the horizontal line test. So when I swap x and y to form the inverse, it's definitely not going to form a function. It's not going to pass the vertical line test. This is actually a good graph for you to see that symmetry around the line y equals x. If I imagine the line y equals x here, in fact, I can just stick that line in there so you can see it. The two graphs are mirror images of each other reflected across the line y equals x. That's what symmetry about the line y equals x means, and that's the characteristic of the graph of a function and its inverse. So how do we restrict this to make it a function? Well, it turns out that the restriction we want is we want cosine to be restricted from 0 to pi. And this will give us just a set of values that takes on every possible cosine value, and when we find its inverse, it will be a function. So here's what a graph of arc cosine would look like. Now we can ask some questions. What if I wanted the arc cosine of negative radical 3 over 2? Well, that's theta. So that must mean that the theta is the angle whose cosine is negative radical 3 over 2. And now if you can visualize it, this was the portion of the unit circle that was going to be produced by values from 0 to pi. And so since it's negative, we must be in the second quadrant. And since it's radical 3 over 2, theta must be 5 pi over 6, which is a pi over 6 reference angle in the second quadrant. That's just an example. Finally, we'll look at inverse tangent function. These are the only three, even though there are 6 of them, these are the three that we're going to concentrate on because these are the three that will be the most useful to us, that will pop up the most often. And for inverse tangent, well, you can imagine the tangent function. If I graphed it in all its glory, I would just continue to get these red tangents next to each other that would span the entire real line back and forth. So the domain restriction that's accepted for tangent to make it an inverse that has a function is from minus pi over 2 to pi over 2. But notice we have to leave off the endpoints of that interval. This has to be an open interval because the tangent at minus pi over 2 is undefined. And indeed, when we swap x and y to make the inverse, there's all those x equals tan y's, and we don't have a function because we don't have a vertical line test. But if we restrict ourselves to just this domain for tangent, then we do get a function. And this is probably the most interesting of the three. The domain of this function is all real numbers. Any real number has a tangent. Any real number could be an angle in radians that has a tangent. The range, however, which is the domain of the restricted domain of the tangent function that we needed, is only from minus pi over 2 to pi over 2. So this is a particularly interesting function. Now, when we're working this one, we could ask ourselves, okay, what's the angle whose tangent is radical 3? Well, if that's the angle whose tangent is radical 3 that we want, then that means that the tangent of some angle is radical 3. Now here you can rely on your right triangle trig if you want to. You can draw yourself a little right triangle and imagine that you had that angle you wanted in there and label it so that the tangent is root 3 over 1, opposite over adjacent. And then you can use the Pythagorean theorem to discover that the hypotenuse is 2. And there you probably recognize the angle that you have. The angle that you have is, see it? Pi over 3. And what if I wanted the angle whose tangent was negative 1? Well, then the tangent of some angle is negative 1. And when I'm going to draw the triangle, well, I want to orient it in the proper quadrant. And for the arctangent function, we're limited to the first and second quadrants because our domain of tangent was restricted to minus pi over 2 to pi over 2. So it's obviously going to be the triangle I want to locate in this quadrant. And to label it so that the tangent is negative 1, these two have to be the same. So it doesn't matter what I put here. I can put 1 here and negative 1. And then a little Pythagorean theorem tells me this is radical 2. And oh, I recognize that. That's a 45-degree angle, reference angle in the fourth quadrant. So that has to be minus pi over 4. because remember, it has to be between minus pi over 2 and pi over 2. And you might be saying, well, what if it's just something weird like the angle whose tangent is 12 or something? Well, for that you would use the arctan button on your calculator. And the calculator is programmed to automatically give you the correct angle within the restricted domain of the original tangent function. And finally, here's a summary, a very nice summary. This is taken from your book, but this is a very nice summary that has all the domains and ranges of the arcsine, arccosine, and arctans, and a nice little piece of their graph summarized for you. And this would be good to memorize. We don't need to, something like the intercept, that we can figure out. And the fact that arcsine is an odd function follows directly from sine being an odd function, if you already knew that. Arccosine, well, this isn't an even function, even though cosine is. And this doesn't have any symmetry. This is a bizarro function. And we don't have to worry about the y-intercept. Of course, it's pretty obvious if you just think about how cosine works. But the domains and ranges of these things you're going to want to know. And you're going to want to know how to make a quick sketch of the graph of these. We're not going to be worried about transformations for these things, but graphs of inverse tangent, sine, and cosine are very useful. And there's your domain of your inverse tangent, all real numbers. And remember that your range does not include those two endpoints, minus pi over 2 and pi over 2. But otherwise, it's the same as the domain of the inverse sine function. And again, don't worry about the intercept. You don't even really have to worry about the fact that it's an odd function. It's useful to know that it has origin symmetry, the same as it is with arcsine. So study these and you'll see their similarities.